Okay, ladies and gentlemen, we're going to start our lecture series on astronomy with talking about the early astronomers, dealing with Aristotle and Johann Kepler, Galileo, and a few others. First, what is astronomy? Well, astronomy is simply the study of the universe, everything from the planets to moons, exoplanets, and galaxies and nebulas, and everything in between. The Greeks were the early astronomers way back, a couple thousand years ago. Aristotle was one of the first ones, and he theorized the Earth was round after viewing a lunar eclipse and seeing the Earth's shadow, round shadow on the moon. Eratosthenes calculated the size of the Earth, and he measured the angle of sunlight between Aswan and Alexandria, and he noticed that the difference in angle taken at the same time on 2 different days was about 7 degrees, and he knew that 7 degrees was about 1/50th of a circle, and he estimated the Earth's circumference at about 39,400 kilometers, and that's pretty accurate. The actual circumference at the equator is a little over 40,000 kilometers. Hipparchus was one of the first astronomical observers, and he cataloged 850 stars, and we still use his catalog today. There are several models of the universe. There's geocentric, meaning Earth-centered. So remember that geo, right here, geo means Earth, and centric means center. Okay, Earth-centered model. Obviously, Earth is not the center of the universe. In this model, the Moon, Sun, Mercury, Venus, and Jupiter, those were the known planets. Mercury, Venus, and Jupiter. Because those ones we are able to see very easily in the night sky. That all these things orbit the Earth. That's obviously not true. And all the other stars remained in the same position in the sky. They did not move. We now know that they actually do move. And this is all known as the celestial sphere. There's a heliocentric model. Aristarchus developed this one for the first time. Obviously, no one really believed him. Helios, helio means sun, and obviously centric is center. Okay, so it's a sun-centered model of the universe. And that the Earth and other planets orbit the sun along with the moon. Aristarchus also used geometry to calculate the distance to the sun and the moon. But this Earth-centered theory dominated Western thought for nearly 2,000 years. It really wasn't until Galileo came along that we have a change in science. So Galileo was one of the first ones to use a telescope to observe space. And this is a mock-up of his actual observations of Jupiter, with Jupiter being the circle. I'll kind of point it out right here. Jupiter is right there, okay? And he noticed that there were actually going to be eventually 4 other stars that were orbiting Jupiter, and those stars are actually the 4 largest moons of Jupiter. And they change position each day. And if you take a telescope outside and look at Jupiter over a week, you will notice that these moons will change position from day to day. And these moons, if you look at them, they're just points of light around Jupiter, and those moons are almost as big as the Earth. Galileo also notice that planets are circular disks and not just points of light. If you look at Jupiter, it looks, on a decent telescope, it looks like a large circle. On a very clear night, with a good telescope, you can see some of the cloud bands. You can see Saturn very, very good as well. Venus has phases just like the moon. This is, let's see, this one right here. I did not take this picture, but that's through a very good telescope. The Venus through the telescope I have at school, that's the picture I did not take, but that's what Venus would actually look like through our telescope. And the moon's surface is not smooth. The picture on the left is a drawing that Galileo made of the moon. And this picture, whoops, let me go back up. This picture right here, this is a picture I took one night through our telescope. And you can see the craters very well and the shadows that these larger mountains on the moon are casting. And that's because the moon has been inundated with rocks and meteors that have been hitting it over the years. And he observed the sun and noticed sunspots that were moving on the surface from day to day, and then he theorized that the sun is actually rotating, and actually is rotating. And these sunspots are cooler areas of the sun. And finally, we have Kepler. Kepler developed the laws of planetary motion. He was a student of Tycho. Tycho. I think it's Tycho, maybe Tycho. I don't know. Anyway, Tycho Brahe. After Brahe died, Kepler continued his work and developed the laws of planetary motion. First law of planetary motion: the orbit of every planet is an ellipse. It is an elliptical orbit, and that means it is not circular. It is elliptical. Elliptical is almost like an oval. So this is the orbit. The sun is on that. The sun is there, and the planet is orbiting along this circle. Okay, and maybe in that direction. So a line, so let's say we have here's our orbit, and here's the sun, here's the planet, okay? A line joining a planet and the sun sweeps out equal areas during equal intervals of time as the planet travels along its orbit. So if we draw a line from the sun to the planet, say 30 days later, the planet is over here. We draw a line. 30 days later, say it speeds up its orbit, and this is not to scale. 30 days here, so this is 30 days, this is 30 days. If you calculate this area and this area, it would be the same. Okay, this is not drawn to scale. You will have pictures that will be better than what I can draw. And then finally, Kepler's third law: longer orbits have longer periods. And the speed of a planet in a larger orbit is lower than in a smaller orbit. Pluto takes well over 100 years to orbit the sun. It does not travel very quickly. The Earth takes 1 year to go around the sun. The equation we have for Kepler's third law is d cubed equals t squared, where d is the distance in astronomical units, and t is period in years. 1 astronomical unit is 93 million miles, or the distance from the Earth to the sun. In the next lecture, we'll do more with Kepler's third law. We'll do some math problems, so you will need a calculator for this, and there'll be some practice problems that I'll have you do. That's it for this lecture. We'll see you next time.